Angle relationships and polygons. A polygon is a figure with 3 or more sides. So we can classify polygons as either convex polygons, where all interior angles are less than 180 degrees, or we have concave polygons where there is an angle of over 180 degrees. We can also classify them as regular polygons, where all sides are equal and all angles are equal, and irregular polygons, where sides and angles are not all equal. So we see we have a regular pentagon, where all of the sides are equal, and then we also have an irregular pentagon, where the sides are not all equal. So we have some common polygons here. We have triangles that have 3 sides, squares have 4 sides, pentagons have 5 sides, hexagons 6 sides, heptagons 7 sides, octagons 8 sides, nonagons 9 sides, decagons 10 sides, a hendecagon 11 sides, and a dodecagon 12 sides. So you can use this as a reference. So solving for the sum of interior angles. This is when we are looking for the interior angles of any polygon. So the sum of the interior angles is equal to 180 times n minus 2. And n is the number of sides in the polygon. Now, if we want to just get the measure of one angle, we can do this for regular polygons only, and it's going to be equal to the sum over n. So we have 2 basic formulas we can work with. So let's do some examples where we have to solve for missing angles. So in our example 1, let's take a look at what shape we have. So there are 6 sides here, and all of the sides are the same length. We can see that this is denoted here by this little line. So this is a hexagon. And we can also see that it's a regular hexagon. So we need to find one of the interior angles, y, and then one of the exterior angles, x. So we need to start off by finding the sum of all of the interior angles first. So sum is equal to 180 times n minus 2. And n in this case is 6 because there are 6 sides. So we end up with 180 times 4, which gives us 720 degrees. So remember, this is the sum of the interior angles. So now that we have that, we want to find the sum of one angle, and this will give us y. Or sorry, not the sum of one angle, the measure of one angle. So we did find the sum of all the angles, which is 720, and there are 6 sides. We end up with 720 divided by 6, and this gives us 120 degrees. So we have y is equal to 120 degrees. Now that we've found y, we can then find x using our knowledge of supplementary angles. So we're going to use SA for supplementary angles. We know that they add to 180 degrees. So x is going to be equal to 180 minus y. And y is 120. So we get x is equal to 60 degrees. So we solved for x and we have solved for y. In our next example, we have a regular polygon that has internal angles that each measure 140 degrees. And we have to take that information and figure out how many sides the polygon has. So we want to remember that the measure of one angle, one interior angle, is equal to the sum divided by the number of sides. So the only information we have so far is that measure of one interior angle, which is 140. So we have 140 is equal to the sum divided by n. Now we also have our sum equation, where sum of all the interior angles is equal to 180 times n minus 2. So what we're going to do is we are going to rearrange 140 is equal to sum over n, so that sum is by itself. And we're going to do this by multiplying 140 times n. Because we have division on the right-hand side, we want to use multiplication on the left-hand side, okay, using our opposites. So we have 140n is equal to sum, or more properly, sum is equal to 140 times n. So now we can take this 140n and we can put it in to our sum equation. So we end up with 140n is equal to 180 times n minus 2. So we only have one variable here, which is n, so we should be able to solve for n. To do this, we need to expand on the right-hand side first, or use distributive law. So we need to do 180 times n and 180 times negative 2. So we end up with 140n is going to be equal to 180 times n minus 360. Okay, the minus 360 comes from multiplying 180 and negative 2. And now we work to get n by itself. So we have 140n minus 180n is equal to negative 360. On the left-hand side, we end up with negative 40n. And then we have is equal to 360. And to get n by itself, we're going to divide by negative 40 on the right-hand side. And we end up with n is equal to 9. So this tells us that this regular polygon has 9 sides. And this makes it a nonagon. Let's do one last example. So we have a polygon here, and we are going to find angle R using our knowledge of solving equations. So the first thing we're going to do is count the number of sides. So we have 1, 2, 3, 4, 5 sides. So we have 5 sides here, and that makes this a pentagon, and it's irregular because the sides are not all the same length. So the next thing we need to do is we need to find the sum of the interior angles for a pentagon. So sum is equal to 180 times n minus 2. And we end up with 180 times 3, which gives us 540. So the sum of all the interior angles is 540 degrees. So that means when we add up the angles S, R, Q, P, and T, they need to be equal to 540 degrees. And we're specifically asked to find angle R. Before we do that, we need to solve for X, and then we can find angle R. So I'm going to start off at S, which is represented by just X right now, and I'm going to add all of those together. So we end up with X plus 35 plus X plus 25 plus 120 plus 105, and all that should be equal to 540 degrees. So we're going to now gather our like terms. So we have X and X and X, so that's going to give us 3X, and 35 plus 25 plus 120 plus 105 gives us 285, and that is equal to 540. Now we're going to subtract 285 from 540, and we end up with 3x is equal to 255. Now to get an x by itself, we need to divide 255 by 3, and x is going to be equal to 85. So this does not give us, it doesn't give us our angle, but it's going to help us find our angle. So we are looking for angle R. So angle R is equal to x plus 35. So now we're going to substitute in 85 for x, add it to 35, and we end up with angle R is equal to 120 degrees.